6 questions to do on page 436 for homework. Signed on Wednesday, we had 1 to 7, except for question number 5. Any issues with those questions? 1 to 7, except for number 5? 8, 6, 7. Any others? Before we do that, let's take a quick look at that equation for the Doppler effect, just to kind of refresh our memory, because it has been a couple of days. We did the activity yesterday. It's been a couple of days since we've seen this equation, and it is a little bit of a tricky equation just because of a lot of variables that sound a lot alike, and that whole plus-minus thing on the bottom of the page. What's the equation that describes the Doppler frequency? What's the equation that describes it? It's on our data sheet. Yeah. Or? Sorry? VW, yeah, good. Good. Plus or minus VS, right? Times, right. And again, that equation is on your data sheet, so you don't need to worry about remembering it. Okay, it's kind of an ugly one to remember, but it's there, so you can just look it up. Now, you do need to remember what each of the things means, though. FD stands for what? Yep. I'm sorry? Yeah, it's the perceived frequency. Technically, we call it the Doppler frequency, but it's the perceived or the apparent frequency as opposed to the actual frequency that's being produced. So we'll write that down here. We'll call it the perceived frequency since that's what you called it, Travis. But again, it doesn't really matter what you call it as long as you recognize that it's what it appears to be, not what it really is. What's FS stand for? That's going to be in hertz, by the way. What's FS stand for? The frequency, Bailey, what is it? Yeah, it's the frequency of the source. It's the actual frequency. And it's going to be measured in hertz as well. So if you've got a fire truck that produces a certain sound, okay, that's the frequency that you want to use there. If you hear a certain sound coming out of the fire truck, that's going to be FD. Okay, the difference between FD and FS, the difference between what you hear and what's actually being produced. Okay, V's are going to be speeds, obviously, but we get the VW and we get the VS. What's the VW? The speed of what? If you're anything like me, the confusing thing is not so much VW, it's VS. And then VS makes VW kind of confusing as well. If you're anything like me, whenever I see VS, I automatically think the speed of sound. Anybody else kind of think the same thing? Speed of sound? It's not the speed of sound. And here's how you remember that it's not the speed of sound. The Doppler effect works for any wave. We usually use it in the context of sound, but it doesn't have to be in the context of sound. You guys know the question, I think it was 7 in your homework questions, involved light, the red shift and the blue shift. Okay, that's light, that's not sound. So we're not going to have an equation that has sound as a subscript there. We're not going to see the speed of sound in this equation. Okay, we're going to see Vs, which is the speed of what? If Fs was the source frequency, then Vs will be the speed of the source. And usually we're going to make that in meters per second. Although technically, you could go whatever units you wanted for this, kilometers per hour, as long as VW is also in the same units. It doesn't really matter. Okay. You know what? For consistency, let's just go meters per second, and then we don't have to get confused about ever forgetting to convert some other time. What does VW stand for? If we were thinking this one was the speed of the sound, but it's not, okay, speed of the sound or the speed of the wave, it's not, then the other one is going to be the speed of the sound or the speed of the wave. We'll call it the speed of the wave because, again, it's not necessarily sound. It likely will be, but not necessarily. The only thing we have left here now is this whole plus or minus thing. And this is, to be honest, what throws me for the biggest loop here. Okay? I never remember whether it's supposed to be plus or minus. Okay? I always have to figure it out. And here's how I figure it out. I know that if two objects are going towards each other, if they're approaching each other, then that's going to produce a Doppler frequency that is what? The fire truck is coming towards you. You hear a frequency that's lower or higher? Higher, right? So that produces a higher FD. If they're going away from each other, that produces a lower FD. And you guys saw the video on that 2 days ago, right, with the fire truck going by. It was a clear difference in apparent frequency as the fire truck went by you. Went from a really high value, higher than what it actually was, to a lower value than what it actually was. All right, if this number is going to be big when they're going towards each other, and it's going to be small when they're going away from each other, how do we use that to determine whether this should be plus or minus? Well, let's assume that we're making it plus. Okay, let's make this a plus. If we make it a plus, okay, then the bottom number right here is going to be a big number, right? If this is a 2 and this is a 5, then 2 plus 5 is equal to 7. We're making the bottom number bigger. If we make the bottom number bigger, then FD is going to be, if you've got 1 over 4 versus 1 over 10, the bottom number is bigger, then FD is going to be a smaller number, right? And if FD is smaller, we've already established that they're going away from each other. The fire truck is going away from you. So when the fire truck is going away from you, you're going to make that bottom thing, that whole plus or minus thing, a plus. Well, that must mean when they're going towards you, we're going to make it a minus. But let's just double check that just to make sure. If this is a 5 and this is a 2, 5 minus 2 is 3. So we're decreasing the bottom number. If we decrease that bottom number, what's the value of FD going to become? Bottom number gets smaller. This number gets bigger, right? And if it's bigger, then that must mean that the fire truck or whatever it is coming towards you. Now, I tell you, every time I see a question, I have to go through this process kind of in my head because I don't remember whether it's supposed to be plus or minus, right? And that's okay. Okay, I'll admit that. Okay, some of you guys are really good at remembering things and much better than I am at remembering things. If you remember when it's supposed to be plus and minus, that's great. But if you don't, remember that you can always figure it out. It doesn't take me this long to figure it out when I'm doing it in my head, right? I just kind of do it, right? And this time I was trying to explain it to you. In the end, you can figure it out in 10 seconds or less, whether it's supposed to be a plus or a minus. Okay, worst case scenario, what should you do? Guess. Just check your guess. Okay, if you calculate FD and you've guessed, just make sure that FD is higher or lower, whatever it's supposed to be. And if it's not, then you guessed wrong. Try again. Okay? Now let's take a look at questions 6 and 7 here, and any other questions if we happen to have them here. 6 says a jet traveling at the speed of sound, Mach 1, although we're not told what speed that actually is, emits a sound wave with a frequency of 1,000 hertz. So that's the actual frequency here. We'll call that Fs, the frequency of the source. Use the Doppler effect equations to calculate the frequency of this sound as the jet first approaches you, then moves away from you. I'm going to copy this over actually so we got a little bit more space to work with this one. Let's say Fs is equal to 1,000 hertz, and that's all we have. Turns out, it doesn't matter what we make the speed of sound here. The answer works out to be the same. Okay, let's make it 350 meters per second. That's a little high. Okay, the speed of the wave is a little high at 350 meters per second. But it doesn't really matter because in the end it's whether we make it 340, 350, we're going to get the same answer. Now, Vs, the speed of the source, tells us it's Mach 1. Tells us we're going the speed of sound. So the speed of the source will also be 350 meters per second. That doesn't usually happen. Okay, we don't usually get a source that's moving at the same speed as the wave is. We want to find the Doppler frequency, FD, when they're going towards us and away from us. So in two cases here. There's two Doppler frequencies that we want to find. One is when it's going towards us. One is when it's coming away from us. So let's do that now. Let's do it when it's coming towards us. Okay, the equation we know is FD is equal to VW over VW plus or minus. What is it? Plus or minus? It's coming towards us. What did we just say a minute ago? When it's going towards us, we're going to make it a negative. So we're going to say it's VW minus Vs. And we multiply that by Fs, the frequency of the source here. VW is 350 meters per second over 350 minus 350 times the frequency of the source, which is 1,000 hertz. So that's what happens here. Okay, 350 divided by 0 is undefined. We don't get a Doppler frequency. It's not a number. It's not a really big number. It's not a really small number. It's mathematically undefined because we're dividing by 0. You guys remember that from math class, right? 6 divided by 0 is, it's not 6. It's not even nothing. It's undefined. That's the mathematical term. It's undefined. In other words, it doesn't have an answer. It's undefined. If it's undefined, we don't hear a Doppler frequency. Okay, does that make sense? We don't hear this Doppler frequency. The waves are crunched together to the point where you don't hear a frequency, period. It's an undefined frequency. To hear a frequency of a sound, you have to have crest, 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 or crest, crest, crest going by you. To hear a high frequency or a low frequency. If they're all together, there is no frequency.
Please excuse the interruption.
Okay. Let's take a look at the other scenario here now when they're going away from each other. When they're going away from each other, the equation is going to become slightly different. We're going to say FD is equal to VW over VW. Can't write a V there for some reason. VW plus VS times Fs. Now, again, we assume the speed to be 350 meters per second, although we don't know that it actually is. Let's put that in here and see how it doesn't matter whether it's 350 or 340 or 260. Or 1, yeah. Fs here is 1,000 hertz. 350 over 700 is 0.5. If it was 340 over 680, then it would be 0.5. If it was 200 over 400, it would be 0.5. So whatever we make the speed of sound there, this works out to be 0.5 inside the brackets. 0.5 times 1,000 is 500 hertz. So if this object is traveling at Mach 1, the speed of sound, you won't hear a Doppler frequency as it's coming towards you. It's undefined mathematically. But as it's going away from you, you will hear a Doppler frequency. You'll hear a dramatically different frequency. Okay, if the actual frequency was 1,000 hertz, what you're going to hear is half that value, 500 hertz. Make sense? Doesn't matter what the speed of sound is. Okay, you're going to hear half the value of the actual frequency. All right. Let's take a look now at question number 7. 7 says astronomers have shown that the color of light from distant stars is shifted from the blue end of the spectrum towards the red end of the spectrum. This is known as a red shift. You can also get a blue shift as well. Okay, from when it shifts from the red spectrum to the red end of the spectrum to the blue end of the spectrum. Astronomers realize that since light energy is transmitted as a wave, light is a wave, the red shift was a result of the Doppler effect. So this is happening here for the same reason as you hear a different frequency when the fire truck goes by you. Okay, light frequency is shifting, just like sound frequency is shifting. We perceive the shift in frequency of the fire truck with our ears. We perceive the shift in frequency of this light coming from this star with our eyes. What does the redshift indicate about the motions of the star, which emits light that we see as a redshift? Well, the first thing that we want to do here is recognize what the frequency of this light wave is. So you guys learned in grade 3 science, the visible light spectrum. It was IGV. Remember that? Red, orange, yellow, green, blue, indigo, and violet. Remember that? You guys all remember that, right? That is probably about the one thing that you learn in elementary school. The one specific thing. I mean, of course you learn to read in elementary school, and you learn to add, and you learn to do all this stuff that you remember for the rest of your life. But that's probably about the one specific thing that you learn. Okay, the one specific piece of knowledge that you learn in elementary school that most people actually remember for the rest of their life. Roy G. Biv. Okay, and they may not remember what it means, but they remember Roy G. Biv. Red, orange, yellow, green, blue, indigo, and violet. Red has a low frequency. You wouldn't have learned that in grade 3. But now we know that red has a low frequency, and violet or blue has a high frequency. So the further to the right that we get, the higher the frequency gets. Now, we're going to talk about 2 types of shifts here, the red shift, and although they weren't asking for this, we'll talk about the blue shift as well. If we get a red shift, what's happening? Well, if we get a red shift, let's say the color of the light produced by this star was green. Or let's say the color of the light produced by this star was a couple of different colors, yellow and green, or yellow and green and blue. Okay, if this star is traveling fast enough, or we're traveling fast enough, as long as there's enough relative motion between us, then that may shift to either blue, okay, or it may shift to red. When does it shift to red? Well, when do we get a lower frequency? Okay, if our actual frequency is green, okay, let's say we start off in both cases with an actual frequency of green. How do we get a lower frequency? How do we get a lower frequency sound wave when the fire truck is going by us? When it's coming towards us or going away from us? When it's going away from us. So if we get a red shift, that tells us this star is going away from us. In other words, this star is receding. It doesn't tell us what the position of the star is. It doesn't tell us how far away it is, where it is. It tells us which way it's going, because it's going away from us. Does that make sense? What if we get a blue shift? Well, a blue shift is a higher frequency than green, right? If we get a blue shift, then that means this star is doing what? We're getting a higher perceived frequency than actually exists, so it's coming towards us, just like the fire truck coming towards us, right? So we'll say for this one, it's the star approaching. I'm sorry? What about it?
If you look at sound, ultrasound is above what we can hear.
Yeah.
Ultraviolet is above what we can see.
Yeah.
Which means it's at a higher frequency. In red. Infrared is below what we can see.
Yeah, that's right. Yeah. Infra means below and ultra means above, and that's in Physics 30 we talk about the entire spectrum: radio waves, microwaves, infrared radiation, visible light, which consists of red, orange, yellow, green, blue, indigo, and violet. We talk about ultraviolet, we talk about X-rays, and we talk about gamma rays, and we spend an entire unit on that spectrum. And the way that I teach people to remember the order of those starts off with visible light. Visible light consists of Roy G. Biv. And then, of course, below red, what are we going to have? Infrared. Above violet, what are we going to have? Ultraviolet. Okay. No, you're right. You're absolutely right, Rucker, but in the end, we don't need to know much about it here this year. Yep. Yeah, you know what? To be honest, I'm not sure. We call it a blue shift, but I'm not sure if it's more of a blue or a violet. It would depend upon how fast it was going. I'm not sure, to be honest. Maybe they call it a blue shift because it's easier to say blue shift than violet shift. Okay, but maybe it might be an issue of it can't get going fast enough to shift all the way to violet. So I'm not sure. I don't know. Maybe red is easier to say than orange. Orange shift, red shift. I'll tell you why they call it red shift, because nothing rhymes with orange. Red shift, you remember by saying red shift, smed shift, bed shift. Hey, it all rhymes. Nothing rhymes with orange. That's why they call it red shift. I don't know. I'm not sure. I think it's just because it's easier to say. Red and blue are common colors. I think that's why it is, to be honest. Yep. Any other questions with that page? Page 436? Okay then.